implementation of the system from the OntoCommons perspective, right? So we have a series of talks starting with Dr. Arkopaul Sarkar from ENIT, who is going to talk about Ontology Commons EcoSystem, ontology standardization guidelines, and alignment tools.
Thank you, Gerhard. I will just grab a glass of water. Okay, sorry, needed to have this glass of water, still food in my mouth probably. So you were hearing about OntoCommons EcoSystem, this OCES in the previous presentations, but then I got this opportunity to talk about it a little bit more and then show different components what we are building under this OntoCommons EcoSystem. By the way, I'm Arkopaul Sarkar. I mean, some of you know me already. For who doesn't know me, I am a member of OntoCommons. I'm from ENIT, and I'm a researcher there. I am working mainly on the domain ontologies, which is in Work Package 3, but I am also involved in the in some part of the mid-level and the top-level ontologies as part of Work Package 2. Does it work? Okay. So as you have seen this slide already in Heidi's presentation, so this is the most tangible outcome of OntoCommons project, OntoCommons EcoSystem as we call it. In a brief definition of it, it is an ecosystem which at the heart of which is a stack of ontologies which are kind of stratified from the top level to the more domain specific ontologies in the bottom. But at the same time, it also has the methodology and the tools which it kind of also proposes as part of this ecosystem. So the goal is to have intra and then cross-domain data documentation. And to facilitate that, we have different components. For sure, the interoperability will be enabled by this harmonized vocabulary from this stack of ontologies, but at the same time, we have the tools to evaluate the ontology and also search the some suitable ontology for your requirement, also recommendation, and also do data documentation, all sort of things. I will show some of this in the later slide. But starting with this stack of ontologies at the heart of it, because it is kind of the most important part and also most complex to develop, what we are trying to do is to create interoperability through the alignment of the ontologies, and the alignment is being done at different levels. For sure, there is syntactic alignment we are trying to achieve, so the common formats, but also the terminological and semantic alignment, so they are also kind of formally aligned. And this is being done through this, as I am saying, this stack of ontologies. At the peak of this pyramid, as you can see that there are a number of top-level ontologies which we are admitting to this ecosystem. And this is something unique to this OntoCommons project, because most of the ontology-related projects or projects which are using ontology, they normally subscribe to only one top-level ontology if they do actually. I mean, but we are admitting multiple top-level ontology as part of this, this paradigm, which we are calling pluralist approach. And the idea is that many different ontologies, existing ontologies, are following one of those top-level ontologies. So we want to accommodate as much as ontologies possible, those domain-specific ontologies. So if we can bring these different top-level ontologies in our coverage and have some kind of alignment between them, that alignment can then flow down and then help us to integrate all these different domain-specific ontologies. And this is what we are trying to achieve here in some more detail. That in the end, then, of course, these top-level ontologies are being adopted in different domains. So, of course, if we are making sure these ontologies are following the same top-level ontologies, then they have some kind of interoperability. But then if we have this top-level alignment between the top-level ontology, then you can also achieve the cross-domain interoperability. So you can go from one domain to another, which are extremely distant, probably. And this is true for, say, also the scope of this project, where the materials and the manufacturing concepts are extremely diverse and different sometimes. So just to then go in the detail of what is the current status of this alignment in the ontologies, we call this top reference ontology. However, there is no ontology as such. Like, this is the mapping between different top-level ontologies. We call them top reference ontology, and this is the work here in this area is extremely formal. So we are making sure that all this mapping between the concepts of different top-level ontologies are axiomatically grounded. So that means that they are proven by a set of first-order logic axiom, which are complete. That means that we can say that this type of alignment can be depended for the lower level, alignment. However, this type of rigorousness is not possible to maintain when we try to bring them to the workable formats like, say, OWL or something similar. So there are some assumptions made, and we took different, help of different tools. For example, SWRL rule can express some of this alignment, which are extremely formal in terms of first-order logic, but some portion of that can be captured by this SWRL rule. Also, some of the OWL DL axiom can also capture that, not fully. So now this is the top reference ontology. Now we also have these mid-level ontologies, which are kind of domain neutral, but then also have some of this domain related concept acting as a domain reference kind of, or helping the domain reference to be unified kind. And then that mid-level ontologies are used by the domain level ontologies, which are more specific to domain. And now this mid-level ontology and the domain level ontology, these are more specific or close to the user, who actually, who can be also the domain expert who wants to use the ontologies. Sometimes in our observation, the rigorousness and the complexity of the top-level ontology makes it kind of extremely hard for them to adopt it in their own work. And also the notions from different domains which they try to bring to the ontologies is hard to unify them under this completely domain neutral metaphysical concepts of the top-level ontologies. So for that reason, we have brought this concept called bridge concept, which also Hedy mentioned in the morning, and which is one of the important element of OntoCommons ecosystem. And these bridge concepts kind of glue together different ontologies at the mid-level and at the domain level, and then try to unify the concept under the top level or the higher level ontological concept. And then also by this way, you can create a kind of import stack for this ontology. So if you use an ontology in your domain application, for example, say you want to use it for your crystallographic application in your in some of the simulation, maybe you can use EMMC crystal. You can find that this import stack of ontologies will go until it reaches to some of the top level ontologies. So this import stack, as it is inbuilt, what it gives you that an assurance that, okay, if you are using this EMMO crystal, then you are using some of these top level ontologies, and if all these import structure hypothetically are present, then you can talk to some other data which is using some other ontologies in this domain probably, because they are also following this same structure and going back to this top level ontology, one or the different ontologies. But then even if it is different top level ontology, you don't have to worry, because there are this mapping between the top level ontologies. For example, some can use BFO, some can use EMMO, but then as there is a link between BFO and EMMO, these domain level ontologies will be also interoperable. And now a little bit on the bridge concept. This is more like an adapter, an universal adapter. This is not an ontological concept. This is external to the ontologies, but then you can use them to glue different ontologies together. And more on the use of it and the benefit of it, I hope I will get some opportunity on the day 3 where I can show some real demo where I will use this bridge concept to map two concepts from two different ontologies together. And then you can see how it can help in sharing data from two different ontologies, and also help you if you do something wrong, it can actually bring you those errors together. Okay, now enough about ontologies, but then as I said, the OntoCommons ecosystem also has these methodologies and tools which can help you in harmonizing the ontology engineering. So in terms of methodology, we adopted the LOT, linked open term methodology, but of course we have given our input on that, and it has been enhanced a little bit. Also mapped the different tools which can be used for different phases of this LOT methodology, and it has been kind of also, we created this detailed map of different tools, which you can use for different phases. It's not very visible, but just to show that, I will show some of this tool, in the later slide. Also, another element is called OCES technical principle. It is more like a guide to the developer's guide, you can say. And so it gives you the how you can form the good IRI, a resolvable IRI. How can you maintain the metadata so that even fairness and then other steps are kind of maintained. Also, it talks about the language expressivity, reasoner, prover, and stuff like that. So it is kind of like a developer's guide who are really developing the ontology. It will be really helpful to harmonize the process. About the bridge concept, and this is, I'm not going into detail here, but we have a system how this bridge concept will be built, and there is a And there is a template, we call it bridge concept template, which we proposed and we use heavily to align ontologies at the domain level, at the mid-level. In the requirement engineering, we have several templates. So one is called Ontology Requirement Specification Document, which we kind of standardized and used it heavily. We have many examples from our use cases where we use this template to capture the requirement, which can act as an example for the future projects to adopt this template and use this methodology to capture the requirement in terms of competency questions and stuff like that. Then we have also this tool. Now I'm going to give you some snapshot of this tool, which we built specifically within the project. Also, of course, we support all the tools and recommend, but then, yeah, I'm almost done. But just to give you a snapshot that one is this industry portal where we are trying to curate and maintain all the ontologies we can find in from our service, and then also we will expand this to others. And this will not only store the ontologies, but also have a link to the ontology editors, which we are working on this ontology editor tools. One is Solosens and another is Ocean. And they will be linked to this kind of ecosystem where you can use them from a kind of one-stop shop. Also, you have a fairness evaluator kind of integrated. So we call that OFAIR. And this is kind of like a summary. You can say that, I mean, you can see the different tools which are kind of mapping to different phases and the methodology as a whole. And that is probably all from me.
Thank you.
Thank you.
Thanks, Arko, and thanks
Any
for
questions?
sticking to the 50. Yeah, I have to go to. Sorry, online guys, I'm here. Thanks, Arko, and thanks for sticking to the 15 minutes. We've got some question time at the end, so we will do it then. We will now go to the next presentation, which is going to be given by Evgeny Kharlamov from BOSCH, and the presentation will be on use case DOME4.0 and OntoCommons lessons learned for ontology-based commons semantically empowered industry 4.0 at BOSCH. Well, we're looking forward to that.
Thank you.
Any of the slides?
Okay.
I'll just
Okay.
tell about 2 minutes.
Okay. It's in the folder.
Yeah.
This one, yes.
Okay. Well, oh, how do I make it? Yeah. Okay.
Mm-hmm. Oops. Okay, good. Okay, right. So we will now talk about the BOSCH use case. And I'm from BOSCH AI, leading there and the direction about neurosymbolic AI, combining ontologies, knowledge graphs, and deep learning all together to enhance mostly manufacturing, but also autonomous driving is one of our fields. In OntoCommons and DOME, we have 2 use cases. One use case is about, by the way, does the mic work fine? So it's good? Okay. We have 2 use cases. One use case is about smart manufacturing, about welding. Another one about plastic simulation. They all are about manufacturing, but one is more like discrete processes, another one into the continuous and into some simulations and analysis, actually. So here, just a couple of words about the use cases. So welding, the idea is to optimize welding to make sure that the welding spots, when you put 2 electrodes together that create welding spots and connect metal, that these spots are of good quality, to reduce the number of errors, or to reduce not necessary errors, but to make this pods of a better quality, so that and to monitor them continuously. And we do this with the help of ontologies in both OntoCommons and DOME. We came, of course, we come with the similar challenge, but then they deviate in the standardization of ontologies and in the data search directions in the two projects. But essentially, we use ontologies that allow us to unify welding data and background knowledge. Background knowledge coming from the welding processes, from also machine learning routines. And the standardization of the welding ontologies, this is one of the key things that we do. And we also look at the democratizing of AI using ontologies to enhance machine learning pipeline development, also with the help of ontologies to predict the quality of those pods. For plastic simulation, the idea is that we use ontologies in order to optimize the simulation processes to make them faster and cheaper, in the sense that we try to reuse pre-simulated, pre-processed data and to discover this data and put it in the simulation pipelines, and ontologies help us in that. And the second one is jointly with the Fraunhofer Institute, the second use case. So, in terms of the OntoCommons, where we are in BOSCH, I would like to give just a little bit of context of OntoCommons and then actually beyond OntoCommons inside BOSCH. The standardization activity in BOSCH, which is actually running for the last about 3 years in parallel with OntoCommons and also with synergies across, is that in BOSCH there is this movement towards having high quality standardized semantic models. We have STEADY as the place where we deposit and store about 500 ontologies, hopefully high quality, and also we work on creation standardized ontologies based on international standards, on good practices. For example, Industry 4.0 ontology, which is there in the middle, so the laser doesn't work so well. Maybe the mouse. Actually, mouse does it better. So this IC-driven standardized ontology. And now there is also a big thing in BOSCH to bring standardized ontologies further into projects which are beyond BOSCH, namely in Catena-X, which is built on top of Gaia-X, the data space, this standardization initiative. Catena-X idea is to do this data sharing across the automotive value chain. It is a predominantly German-driven project, and their BOSCH role is, one of the roles is to bring standardized ontologies into the game to enable this data sharing across the value chain. There are quite many things related to ontologies happening in BOSCH and related to standardization of ontologies. And OntoCommons is one of the parts in the puzzle to make the bigger picture and to ensure that we have these high quality semantic artifacts. Now, more concretely, our lessons learned in projection to the use case of OntoCommons, to the welding. What have we done there? So we've been developing, we've been adapting the processes of ontology development for the use case, and we've been cross-referencing that with the colleagues from OntoCommons. We developed artifacts, the welding ontology artifacts. We analyze them on the fairness principle, and we also made sure that the artifacts we have, they are based on top-level ontologies, for example, on this sensor ontology and other ones, international standards. So the ontology that we developed and in the framework of OntoCommons follows some of the initiatives, some of the guidelines, and also we continue developing that. So we have more things to go and to further verify what we have against the OntoCommons benchmarks. We do this. We've been doing it with one intern from Galway, and now we are also discussing. We're expecting a couple of interns to come from Trento and Madrid, from the OntoCommons family, to continue this work. And we are also hiring a PhD student. We were looking at the time when it would be the best to start also the PhD student, but we are looking that for us, OntoCommons is not, when it finishes, we're not considering as the end of the story. We would like some sustainable model of going further and to build things on top of the OntoCommons outcomes. And of course, the main thing we'll get from OntoCommons will be closer to the end of the project. So when all the things are already developed, all the standards and the guidelines will be at the place. And our vision is to take it and then to go further with some young professionals. And as a spin-out initiative, we are forming working group alliance for discrete manufacturing, where we discuss it with Siemens Energy, University of Oslo, Total Energy, BMW. Some are from OntoCommons, some are from outside of OntoCommons. We already had a workshop last year, so we see that we can take it further and then go beyond OntoCommons and to keep the momentum to make sure that the tangible results are not lost, but taken further and further developed. Then, in terms of DOME 4.0 and where it meets OntoCommons in the BOSCH case, as you know, in the web story, only the fraction of the data is available and in the surface, and most of the data is in the deep web. So basically, in databases hidden. Same thing in BOSCH. Enormous data across BOSCH. A number of search systems exist across BOSCH, but mostly they're focused on the surface, on finding things for documents and so on. Dataset search is not as prominent as one would expect it to be, which is not unusual in industry in general. And we see DOME and data marketplace as a great opportunity to uncover this hidden data, to make sure that BOSCH knows what it knows, and at the same time BOSCH knows what it does not know from the external data sources. So in-house databases, we do need to get good access to them, and for the external ones as well. And the semantic solutions, this is the one that we see a great way of doing that. Namely, what we see and what we do in our use case is to show how we interlink various databases and various data sources and make them available through the marketplace, discoverable, and then apply and then combine together. This is of course critical for the project like Catena-X, where the idea is that data is shared across the value chain, means like lots of databases become available, and for example, marketplace as the place to share them. We also do in-house research in dataset search. We have a bunch of papers. So the last one was just published in a journal in February 23. Oops, it's the end of the talk. Okay, good. Okay, the last one was just published on the benchmark for dataset search. Because marketplace offers the place to share the data, but of course data should be discoverable with smart keyword or some other searches. Data should be, when it's found, represented in a way which is consumed by the users, that they know why the data is there and so on. So we do these type of things, and we are envisioning embedding our AI algorithms for dataset search in the DOME platform. So this the way that OntoCommons and DOME is connected inside BOSCH can be seen in this workflow. So the data that we possess, the manufacturing data, is described and become available through the standardized vocabularies, ontologies, which we develop in OntoCommons, and also become discoverable through the ontologies developed through DOME, which are harmonized. That allows us to shop for the right data, and then take this right data, push it into the AI with the help of AI and machine learning and welding ontologies, also developed in the context of OntoCommons, and then we can do the task of welding quality prediction or material simulation, enhanced material simulation. That's how it is connected inside BOSCH, the projects and the things which are happening. And in terms of how this is linked on the ontology level, so on ontologies we have unified welding data and background knowledge represented through ontologies, and the marketplace ontologies interconnected. That allows this marketplace and the data representation to come together. And we look at three collections of data sets. BOSCH production data, which is in BOSCH in-house, and then the data which is discoverable through marketplaces. So we're positioning, we're loading, exposing data of relevant for the welding case. The customer data, which is for the internal search, synthetic data, also for the external search. And the idea is that we, through this search of the relevant data sets, we put them together and then do quality prediction for welding much better than with the data sets that are in the BOSCH possession alone. Similar thing in the material simulation. So we take the data which is needed for material simulation, expose it, some of it through marketplace, discover this through marketplace, take it through marketplace, combine with the data which is available at hand. So the marketplace data from Fraunhofer, in-house data from BOSCH, brought together, and then they give this effect of much faster, much cheaper simulation than if we do it without the data coming from Fraunhofer. So this is how this works in practice. This is our demos which we are targeting to be presented on this discovery and the use of data for improving the processes within the DOME project. That's it. So these are the things. Yep. Yes.
Well to the time, and yeah, we'll come back to the discussion again, as we said. So the next presentation is going to be given online. So Huanyu, are you there? Can you hear me?
Yes, I'm here. Okay.
And hopefully we can hear you. Not yet at the moment. Is he online? Yeah, okay. So if you could share your presentation, then hopefully we'll be able to see it here in the room.
Yeah, let me...
Hello, can you hear us?
Yes, I can hear you. Can you hear me?
Yeah, now it's better. Thank you.
Oh, yeah. So let's...
Can you see my shared screen?
Yeah, we can see the screen. Yeah, that works very well. Can we just check for the sound again? Because it was not...
Clear? The sound okay now?
Yeah, if you speak loudly, then that...
Okay.
Thank you. So over to you.
Okay, good afternoon, everyone. My name is Huanyu Li. I'm a postdoc from Linköping University. I'm glad to give a presentation today in terms of our demonstrator in OntoCommons, which is materials databases integration using the Materials Design Ontology. So I will follow this agenda to introduce our demonstrator. First, I will give some information about the background and the motivation of our work. Then I'll introduce two main work, which is the Materials Design Ontology and ontology-driven data access and data integration in our demonstrator. Finally, I will summarize and introduce some ongoing work of our demonstrator. So first, let me introduce the background and motivation. Nowadays, there are many different softwares can do materials calculations and provide reliable materials data. At the same time, quite a lot of databases have emerged in recent decades. The researchers can not only upload their materials data to these databases, but they can also get the data and use the data in their data-driven workflows. There are, I show three well-known databases in this slide, which are the Materials Project, OQMD, the Open Quantum Materials Database, and NOMAD, Novel Materials Discovery. Well, the availability of such databases can provide a hub for the data-driven workflow. Some problems appear when people need to query data from these different databases, since these different databases usually are heterogeneous in nature. So for instance, if one wants to search for a material with the composition gallium nitride in these three databases, the result is slightly different from different databases. We can see that for each of them contains a column that represents chemical composition, but with different column names or some different insets. For example, in materials project, it's called formula. In OQMD, it's called composition. And in NOMAD, it's called formula, but it's actually not the simplest ratio of different chemical elements in the formula. Ongoing effort in the domain of materials design is optimize open databases integration for materials design, which aims to alleviate such problem. It aims to make materials databases interoperational by developing a common API. Some work in our demonstrator is inspired by this optimized consortium. So we see that we need some semantics and common terminologies to make the data in these databases interoperational. We can represent the semantics in ontologies. Of course, ontologies can help in standardizing the terminologies, and ontologies can also help to make data fair, which is short for findability, accessibility, interoperability, and reusability. So for materials design domain, we see the need that a semantics-aware and integrated way for querying data among heterogeneous data sources. We can apply ontology-driven approach for data access and data integration. But before doing that, we also need to construct ontologies. We also need to develop ontologies for the domain. Since there are no domain ontologies can be used at the moment for data access and integration when we started the work. Although we see ontology-driven approach can play a role in data access and data integration, there are still challenges. For example, classical ontology-based data access and data integration approach, they focus on relational data that can be viewed as stored in relational databases. But in materials design domain, and also in many other domains, data can be modeled and shared via different ways. For instance, data may follow relational model and non-relational model. Data may be shared and queried by different APIs, and the response of data may be shaped in different formats, for example, in JSON format or CSV format. So there is not much work on providing semantic and integrated access in materials design domain. Neither formal methods for constructing some methods or some approach to make a semantic and integrated query to different databases. So first, we developed the materials design ontology. So we followed the NEON methodology. Basically, we conducted the requirements analysis. So for example, we identified the use cases, competition questions, as well as some additional restrictions that we expect the materials design ontology to answer. And we reused some concepts from existing ontologies, such as the provenance ontology, QUDT ontology. And we developed the materials design ontology in different modules, which are a core module, structure module, calculation module, and the provenance module. During the development, we discussed with a domain expert to decide what concepts and relationships to be included in the ontology, as well as some axioms that the ontology should cover. This figure shows the concepts and the relationships within the materials design ontology. There are 4 different modules in the ontology. In the middle is the core module, which contains concepts such as calculation and structure that are also used in other modules. Then we have the structure module that we modeled some concepts and relationships to represent domain knowledge relevant to structural information of materials. In the calculation module, we modeled several computational methods related concepts and some key concepts relevant to one of the main computational method, density functional theory method. Then we also have the provenance module, which is mainly about building the connections between calculation and the software agent, as well as structure and reference agent, to state, for example, which software produce the calculation data and which reference, for example, a publication publish structure data. Here we have the concepts and the relationships we reused from QUDT ontology. So the second aspect of our demonstrator is regarding ontology-driven data access and data integration, where we developed a GraphQL-based framework for data access and data integration. So in this framework, basically we have 2 parts. The first part is the GraphQL server generation process, which we make use of ontology and semantic mappings to generate a GraphQL server. So the GraphQL server can be used to access different databases. Then we have the GraphQL query answering process is once we set up the server, we can ask GraphQL queries to the server, and the server contains some implementation to access underlying data sources, then get the data back and structure the data according to a GraphQL schema. So what is GraphQL? GraphQL basically is a conceptual framework for building web APIs. The framework introduces the notion of a GraphQL schema, which describes the data that can be requested from the backend data sources. And in addition, the GraphQL framework contains resolver functions, which are responsible for accessing underlying data sources and structure the data according to the GraphQL schema. And also the framework introduces GraphQL graph query language, which allows users to write GraphQL queries. For example, based on the materials design ontology, we can generate such a GraphQL schema. For example, we have the type definition for different concepts in the ontology, and then we have the field declarations for different data properties or object properties in the ontologies. For example, here in the schema, we have the calculation type that the calculation has the ID, which the returned type should be in string. And also it has the field definition has output structure, which the returned type should be a list of structure. So based on our tool, we can generate such a GraphQL schema based on the ontology. Then we can write some queries according to the GraphQL schema. For example, in this query example, it asks for calculations, while the calculation ID is in a given list, and the reduced chemical formula contains some different chemical elements. Now I would like to introduce some ongoing work and as well as summarize our demonstrator. So in our work, we developed the materials design ontology. It is capable to represent basic domain knowledge for the materials design domain. And we use the ontology to generate some mappings among different materials databases. And it can be used for enabling some materials databases search. And for our GraphQL-based framework, we have already started to develop a web interface to interact with the GraphQL server so that users can write some simple queries instead of the complex GraphQL queries. Then in our demonstrator, we are also investigating the compatibility of our materials design ontology and top-level ontologies, for example, MO ontology. So we are working on aligning MDO core module with EMMO. As well as we are working on extending MDO with some new concepts and relationships. For example, there will be a new module added to MDO, which is about different properties. That's all my presentation.
Thank you. Thank you very much for your presentation. Hopefully you will be able to stay in the session until the end when we have some questions for all of the speakers. Okay. So come and thank you for now for the presentation. So we will then move on to the next presentation, also online. I hope we will have now Emanuele Ghedini from University of Bologna to give a presentation on the alignment of DOME4.0 with OntoCommons.
Can you hear me?
Emanuele, yes. Yeah. As before, yeah, if you speak kind of loudly, okay. Speaker on our side is not the greatest. So nothing on your side, but it would help us here in the room. Thank you.
I will try to speak loud, but not to scream. Just let me. Okay. Okay, so today I'm going to talk about OntoCommons and DOME4.0 ontological relations. So check time. So DOME4.0 is a project that relies on an ontology-based architecture using a semantic data exchange ontology that is aimed to document the data set that are hosted by DOME4.0 and an ecosystem ontology that has been developed by UKRI. I will focus on the first one, on the ontology for the dataset documentation. The aim is to develop an ontology for semantic exchange of data, so placing the data into a larger knowledge network based on ontologies. And another objective of this ontology is to align with the OntoCommons project and also to provide a syntactic representation for the dataset. So the idea is to provide something more than a simple RDFS documentation of the data using, for example, the DCAT ontology, but to go a bit further by providing through the DOME dataset ontology a top-level ontology like the MMO that is aligned to the OntoCommons ecosystem, what we call semantic enhancement. So placing the dataset into a framework that can be called an ontology, so that express knowledge and relation between knowledge entities that can be used by a reasoner to infer new knowledge or to impose a constraint. So how to do that? We know that there exist several RDF vocabularies and schema that are aimed to document the data that are widely used and understood by several communities, like, for example, the Dublin Core metadata, the data catalog vocabulary, DCAT, the friend of a friend vocabulary, the PROV data model ontologies, and so on. However, while these RDF vocabularies are really useful, the permissivity of these vocabularies prevents the introduction of more sophisticated axiomatization and impose so what we want to do is to try to project these vocabularies into a larger environment that is based on a richer language like How2DL. So what we did in DOME4.0 is to select a starting list of concepts that should be gathered from DCAT mainly, and then to see if it is possible to express this same concept using an ontology that is far more richer than a simple RDF vocabulary like the MMO. So when you want to do something like that, so moving from RDF to OWL, it happens that you have RDF property types that are representing the relations between the entities. So for example, you can represent the creator, you can relate the creator to a data set using, for example, a textual annotation or an individual. So it's very permissive. But in OWL, there is, in order to enable reasoning, you have to specify what type of property you are referring to, if it is a data type, an object property, or an annotation property. So this is what we want to do into this framework. So for example, if you have a document that is instantiated as an individual, what you can do to document this this individual is to, for example, now use an annotation property. So you attach simply a text string to this document. Or you can use a data property in OWL to say that this has author John Smith. But these two ways to document a data set are making use of non-logical statement. The first one, an annotation, is non-logical because it cannot be used by a reasoner. And also the data properties is partially non-logical. A reasoner can use this information, but this information, this relation, this data property relation is not used by a reasoner to infer new knowledge as done in the object properties that are actually part of the logical framework and can be used to a reasoner to impose constraint and infer new knowledge. So our idea is that semantic enhancement is something that helps you make you able to represent most of the knowledge using individuals that are have a place in an ontology in a formal way. So using logical statement. So that's how we want to enhance the existing documentation by trying to move from a simple documentation that uses RDF property intended as a notation or data properties into something that can be used by a reasoner. So here it is an example. On the top here you can see the DCAT dataset concept, and here you can see how it is mapped in the MMO. For example, in the MMO we have a more sophisticated concept of dataset. For example, dataset in DCAT is not clear if it is considered, if it is the dataset that is materially generated, or it is a dataset in the sense of abstract content. So this is not so clear. So what we want to do is to make this clearer and to place this concept into a larger framework. The same is for the keyword. In DCAT, you have the keyword property that in the MMO can be extended in order to define keywords that can be used to semantically enhance the dataset. For example, you can create a syntactic keyword, so simply adding text to a dataset. Or you can use a semantic keyword in which you can specify the type of the dataset. You can specify how this dataset is semantically connected to another entity, for example, using the semiotic relation in the MMO. Or you can provide more information, like, for example, what type of tool you can use in order to open this dataset, and so on. Another example is the creator, the relation between a dataset and its creator. So in DC terms, the creator has range agent. So here you can see the DC term environment, and down here you can see the MMO environment in which the creation is a process that connects entities that are more, semantically meaningful than what can be done in a simple RDF vocabulary. So, if you use an ontology to document your data set, you have several benefits. For example, the possibility to use reasoning, to apply constraint and increase the quality of your database documentation by imposing consistency. You can infer new knowledge. You have interoperability, because if you use this knowledge framework is much more clear, specific, and documented, so you can enable interoperability between disciplines. And also the expressivity of what you can say in an ontology is larger than what you can express in a simple RDF vocabulary. And especially ontology bubbles up knowledge towards the user, reducing the need for data analysis and complex queries if you are clever into creating actions. So here is an example of the MMO structure in which a strong merio-causal foundation is used to create perspectives that enables you to represent the things using different way to look at the world. For example, the holistic perspective, the physicalistic perspective that is devoted to matter and field, the reductionistic perspective that is designed to represent the granularities of nature of things, the data perspective that represents data and how they are formalized. In fact, in the MMO, the union of perspectives is the way in which we reach the more powerful, the more interesting results. For example, in the MMO, we have a clear separation between syntactic and semantics in order to represent information. That is the way in which the MMO helps you to represent a data set and to represent the entity for which this data set has possessed a meaning. So, for example, if you have a document like the one you see on the left, and it is represented by this individual, it is possible to connect to this individual data that you declare being already part of the data set, or to connect to this data set properties, for example, the rate, the reader's rate for this book that are generated using a book evaluation process. So you can, using an ontology like the MMO, in this case, connect the metadata and provide also the provenance of the metadata that you use to document your data set in a really expressive way. Another, this same approach can be used to connect properties like a physical quantity to a material. So keeping track of the simulation process or the characterization process used to generate these properties. But this approach goes beyond the MMO because, as Arko already showed you, we wanted to make use of ontologies that are part of a larger framework that should be able to put together several ways to describe the world using ontologies. Here you can see something that Arko already showed you. So the structure of the part of the ecosystem that tries to put together top level and mid level ontologies together in a common environment. That is that it can be found in the GitHub OntoCommons GitHub repository. It is still in development version and will be released at the end of the OntoCommons project. So you're going to have an environment in which you can find the concept that you may want to include in your data set. So there is no point into asking people to enhance the data set without the people being able to navigate the ontologies that help them to enhance the data set. So this OntoCommons framework is exactly what aims to do like that, to provide you a common ground to represent knowledge and then to navigate this knowledge, for example, using a tool like Protégé, or also the Industry Common Portal that Arko showed in the previous presentation, that enables you to find the IRI, for example, that helps you to say, yes, this dataset is about this concept that I found in the MMO ontology navigating the OntoCommons ecosystem. And in the OntoCommons ecosystem, you have the alignment in which for example, a concept can be connected to two top-level ontologies, so that it is possible to really to respect the possibility for people to commit to a top-level ontology at the same time to use what they request. And this can be done also through the bridge concepts that are already introduced to you, and that will be better addressed in the day 3. The Protégé environment is also able to host the annotation in OntoCommons can be also hosted, the information hosted by the bridge concept documentation that allows you to have to go to the domain resources that are collected in order to better explain what the concept is about, and what, for example, what ISO you refer when you introduce something, a concept like, for example, manufacturing. And the final word is about the fact that this ecosystem is started to be populated by well-known mid-level ontologies in order also to facilitate the usage of already existing formalized knowledge by the communities. So the conclusion, the dataset ontology can open the gate towards ontology frameworks that provides well-documented ontology concept to semantically enrich your data. So an ontologized data can answer complex questions. So you can query your knowledge base with questions like, which software may provide such a data so that I can build a workflow? Which real-world object type is this data stands for? Or what do you mean with viscosity in this data set? Are there workflows that make use of this data set type? So this type of question can be answered using a SPARQL query in a knowledge base that is based on ontology, like, for example, the EMMC. And another important point that also has been addressed by Dirk in the representation of the marketplace is that we need to be to have different steps in the data enrichment approach. We need to be respectful with people that wants only to provide simple keywords, but also give you the possibility to enhance your data set using more richer metadata description for the people that wants to add value to their data set by connecting them to an ontological framework. And this is all from my side. Thanks.
Thank you. Thanks so much, Emanuele. And again, please stay for the discussion later if you can. But first, I'd like to ask my colleague Alexandra Simperler, who's going to talk about the knowledge management translator. In fact, address some of the points that you, I think, also made in terms of the people that like or don't like ontologies, and how do you work with ontologies, and make it all actually beneficial for us. Alex, over to you, please. Share your presentation. And
I will, yeah. So, can you see my presentation?
Yeah, and we can.
I go full mode and hope for the best. Yeah.
Fantastic. Yeah.
Okay. Good. So basically, I bring in the people because obviously in OntoCommons we do all this stuff. We generate tools, we generate workflows and so forth, and somebody needs to do it. So I'll show you now the human resource we plan to do this. So why are we doing this? So there is two existing roles we are expanding. One is the materials modeling translator, which was developed as a bottom-up approach by people engaged with the EMMC to close the knowledge gap between industrial stakeholders and material modelers, to see that they understand each other well. What does industry want? What can the modeler give? And there is on the market a concept of the analytics translator. They are supposed to close the knowledge gap between industrial stakeholders and data experts. And our role will be in between the two of them. We developed 6 steps of knowledge management translation. So we call the new role the knowledge management translator. And we break down the effort. There is some people, they can do this naturally, but you want to give a process. So people, they can do a few of the steps naturally to go through it and have some guidance. So I will show you how this works with a step 0. So I kind of like lied to you from the beginning. There's a 0th step. And we heard this in the previous talks. How ready are your data? And this is very important because when we go in, we need to check what is available and do some sort of maturity assessment. Low maturity is still maturity, so we can do things. And the little semantics, as we know, goes a long way. So once we show the data are okay, we try to help them to find the innovation challenge and elaborate how this goes. So people have some great ideas, and we then say, okay, that's a challenge. We can bring in our knowledge and can do something. And we like our benefits analysis. So we can show you when you do this, there's a lot of things you have to invest, but at the outcome, you will be so much better off. It can be financial. It can have to do with the Green Deal. So we can also take societal challenges and do this. In a step 2, we need to conceptualize, because as we know, data doesn't mean knowledge. So data can be a spreadsheet, looks very impressive, but what do I know if I look at it? So we need to find out, okay, there is this data. How do we get knowledge out of them? This is very important, and get a case. Then we want to determine the relevant vocabulary. So we will look, and as we have seen, OntoCommons does a good job, what is already existent. And if we know about its existence, how can I make these entities talk to each other? So we look into vocabularies, taxonomies, ontologies. Standards are very important because it's a process that enters industry that has a certain standard, and the data, of course. And we check what's there and what's not there, where can we find it? So our step 4 is then we propose a potential knowledge engineering solution. And you can see the OCES is mentioned and was discussed about today already. So this is where we go from. It's a nice tool set. And then we say, okay, we bring in a realistic semantic solution. And the emphasis is on realistic. Yeah? So we can do whatever suits the company on their level, because if we go in full Monty, it's very, very expensive to ontologize everything and make your data ready. Yeah? But realistic is very important. And then we start the implementation work. And here is like that the knowledge management translator is not the person who does it, it's the person who facilitates it. So we then will take knowledge engineers or specialists, they will kind of like implement this work. And once we're done, then we also will do client training. So we have this in place. How can people work this? It's about upskilling the staff. It's about really letting something back in this company they can actually use on a corporate level. So education is very, very important. Never let somebody on their own, because they will never use it, again, if it's very complicated. So this is the 6 steps we offer. And what I still haven't told you, who is this person with all the superpowers that comes into your organization and does this all? So we need to answer, who am I and where to find me? So there is certain features of these persons that's out already. So they need to be a strong advocate and communicator, and basically need to know and like ontologies and semantics and go in with it. They need to believe and to make other people believe as well. A good auditor is a good idea to see through the truth what's there, what can I work with, and advise on the benefits once you can get this into your company, because there will be some pain involved. You need to train people, you need to invest in your data, you may need different way how to store the data and so forth. Then they should have technical skills in ontologies and knowledge engineering, and relevant domain expertise. So we ask quite a lot. And also their project management skills needs to be polished, because they have to work with several stakeholders when they go in. It's not only one person in a company, you need to engage with many. So the qualifications, before I go into this, they strike you a little bit harsh, because I ask a lot. I ask you for a PhD and like 25 years in industry. What does this mean? So we want to hit the ground running. So we need to find people, they engage in this. They could start tomorrow, for example. Yeah, so then they would have a PhD, for example, in knowledge engineering or a physical science, and postdoc or industry experiences to kind of like give me the maturity. So I do not necessarily need a maturity in age, I need a maturity in experience. So have you seen a lot? Yeah, so it could be also somebody who spent dreaming in Python from the age of 5. This is also a possibility. The other way around was I get a PhD in the field of interest, like materials science, metallurgy, biochemistry, and so forth, and then have some experience when it comes to multidisciplinary projects, because at some point you have stumbled across data, they need to make sense, you need to bring in, and either an adequate or education that shows you know about knowledge, or you learned it on the job. So this is two qualifications we can go in and help out with a company and can identify ourselves as a knowledge management translator. So what will they do? They will work closely with the business team. So we must not forget these businesses have been around for a long, long time. So we need to appreciate this and involve them because they know how their business works. And then we want to work with ontology curators, ontology engineers, people that do development and so forth, basically with what we find. Yeah, so we envisage that these people come in with a first aid kit and I can do something on the spot and I have to work with what's there because I cannot expect from every organization to have such a well semantically proven team on board. What is very important is to talk to domain experts to really check if the terminologies are okay. I can curate everything, what fits into this domain. We learn a lot from two projects, OntoTrans and Open Model in this respect, because this is exactly where we come in as the experts, but we get challenged by an existing industry. And then we also should coordinate with engineers to make sure everything has the right place when we start developing. What's the call of duty? So basically you enter the Onto zone, that's a new zone of duty, and you need to be an interface between engineering and the business team. So never let them out, because this is how we reach industry commons. Perform a readiness assessment, and we have seen by our colleagues before there is some nifty tools to see what to do. We also offer one from Goldbeck Consulting to look into your human resource, your tools, your ontologies, your data, your process, and so forth. Identify the innovation case and elaborate the benefits, and this is very important. What is there that cannot solve with other means? What do we have to solve with semantic? Yeah, so why do we bring some value in? This is very important as well. Then we conceptualize the innovation or data to knowledge case. So how do we do this? What's the concept? And then we determine the existing vocabulary. What is there? Okay, but then we can still embark into find something newer elsewhere. It's better to find it elsewhere than start from scratch. And also OntoCommons does a good job with different work packages to tell us about the landscape. So we have some great landscape analysis going that tells you very much what populates this landscape. And then we propose a potential knowledge engineering solution and we delegate the work. So we are consultants and delegation is a second nature. And then we deliver the internal adoption of solution, including training. So we must find a way to engage as many people as possible with it on different levels. So training is very important, and everybody can learn something which helps them in the job. It is also very important from our experience not to dilute this scheme and say, yeah, take one of your scientists and let them learn it on the side. This is not important. This is not possible. Yeah. So we believe that certain things need to stop in an organization, so I can replace them with something newer. Things have to be done differently, but they cannot be done additionally. This is nothing you just can run on the side because this is just ending up in disaster. So we also have to teach people to think differently and create something new. So what is our future? So we have an Onto future, obviously, which I nicked from OntoTrans. There's a second white paper coming out, and it is a lot of experts internally to the project and externally to work with us and give solutions. And they pretty much on the shop floor, so they have seen it before. They have found solutions. They come from education, so we have educators on board and so forth. So we get a very, very broad universe into this white paper to show how we give this role, this first aid kit, how we give this role the tools they need, and also how to educate them. If some of you mentioned to join beautiful Vienna to be at the EMMC 2023 or the second OntoCommons workshop, which will be in Oslo, do come and synergize. So you had the chance with this meeting today to meet some of us. Please do come and talk and share ideas. Yeah, so we want more synergies, more input. Our outcome will be a database with trainings material and expert, a list of experts, because you need to be able to find who could do this now. Yeah, and if I was such a person who could do this, where is my trainings material? How do I get more knowledge? How can I teach myself to be ready for what is needed? We work closely together with DOME4.0 on this, because they have the finger on the pulse where we need to be, and we got some great experience because some of the participants there have been on WIMP to get these databases and this expert knowledge schemes together. And then there's something else we want to do. We want to initiate a Marie Sklodowska-Curie action because we need to teach the new generation. So the idea is to start from scratch, see what's hot in the field, and give them some tools to become one of these knowledge management translators in the future. So we kind of like hit the ground running, as you see, but we also think about the future. How can we fit this brilliant role, we think, with new young, exciting people? And the last slide is basically, thank you very much for giving me time in your conference to talk about this.
Thank you so much, Alex. Thank you, and thanks to all the speakers. Well, by clock time, we are now at the break time, but I look at the organizers here. We should still take some minutes, maybe to get questions, obviously, for the speakers, but really also our kind of remit here is to discuss the question, how can fair data and ontologies combine with digital marketplaces to create materials commons? So any views on that? I think what we have heard is like different ingredients, right? I mean, to make a nice dish, to bake a nice cake, you know, we need to have all of these ingredients together. And I think we've had a really great view now of these ingredients. And we saw some examples also, you know, from the presentation given by Linköping, by Huanyu, on the way in which, for example, different data from databases can be better integrated with semantics. Although, interestingly, there's already a project to do some syntactic integration. There is still a need for people to ask certain questions across that in a more generic way, and I think that was also a common theme in the presentation from Evgeny from BOSCH, that you want to integrate outside inside knowledge or a querying system that works on all of your data. So that's kind of a recurring theme. Then one question I would have, for example, is it on the marketplaces, you know, is it an expectation for a user of a marketplace to be able to ask this type of query about, let's say, materials data or manufacturing data, you know, into, let's say, you know, you're a user and I want to ask the marketplace about that? Or is the marketplace, as we have seen from the presentations also from Emanuele about this data cataloging ontology at a higher level, right? I mean, the marketplace, first of all, says, okay, here are all the data sources, you know, in many, many different domains. But if you want to now look into data source A, B, and C, you need yet another ontology, right, that understands A, B, and C, and then gives you answers across those. Is that a function still of the marketplace, or is that who fulfills that function, right? In the talk from Alex, we have heard, okay, let's assume we have a company, or let's take the BOSCH example. You can build this ontology for your domains of experience and say, okay, for our users, I can build that sort of system, right? Now, you also indicated maybe you build a little industry commons. Sorry, different use of the term. I'm not allowed to use the same term for different meanings. A little group of industry players that say, okay, maybe we can share a little bit together, right? Then you build the system. So this is how I see it. Yeah, so lots of potential, right? But lots of dimensions, and I think that we can get also easily almost lost in the opportunities, right? And it's a question maybe of priorities of what to address first. So I've spoken for very long now. I've pretty much used all the time myself, but please go ahead, and I want to have your reactions now.
About the, does it work, the mic? Okay. Addressing this, the last part of your question about this, what the marketplace can offer, what type of functionality. I would say that ideally, in this scenario, so all the scenarios are ideally to be supported through the marketplace, but not the data, not the search inside the data, but actually search for the data. And internally, when we browse through the BOSCH data sets or through some consortium that form together around particular topics and offer data through marketplaces. But in the ideal world, it would be great to have a data marketplace where, for example, whenever BOSCH would like to buy a new robot for a manufacturing line, we can ask, through a query to the marketplace telling, please give me data from providers of robots, and so that the robots can do this particular operations, for example, drilling. And then ideally one would like to get from KUKA, from other manufacturers, a bunch of data sets that describe how those robots function, give some simulations of those robots, and then we take these data sets as they are, found through the ontology industry for gerontology, telling that there are factories, there are robots, there are production lines, I mean some generic terms, and then by importing this data about robots, one can then plug this data into the digital twin of a factory, do some simulation and see whether this is actually really the right robot for the production, or one may consider another one. So in this case, one can do this search, like in Amazon, you search for the best photo camera, here you search for the best robot, but you're not interested in just a picture of the robot or some short description. You would like to get the data set of the robot that you take, plug into your system, digital system, test this data, see how well they do.
But just to interject here, okay, you mentioned the word drilling, okay? So
Yes.
so that means, okay, you just want the data sets, you're not into the data sets, but what you just said, the marketplace still has to understand the term drilling.
Exactly.
So then I can ask, 100 other people, they will come all with these terms. So we do end up with the marketplace, what is the level of language, right? The vocabulary, the understanding that the marketplace itself has to have, rather than a sub-community that says, okay, we manage our knowledge in this way. Yeah, for me, I mean, I'm asking this genuinely. This is for me still an unanswered question where we don't know yet where the right level is. Yeah, because obviously the marketplace. I mean, if you go into any detailed area of materials or manufacturing, you cannot, at the moment, probably understand everything. Maybe together with ChatGPT technologies, you can absorb enough so that it will understand everything, right? But at the moment, this is not the case. Yeah.
Indeed. So then, yeah, then in the ideal world, ontology would know some of the basics of manufacturing, including some.
Yeah.
But then
What is that?
But where is the exact degree of the basicness and how much it should? Yeah, that's.
And how will the? Is there a question online? I see a red dot on the chat. And also
wanting to know who was.
So this was Evgeny Kharlamov from BOSCH. Oh yeah, please say your name when you're speaking here so that the people online can identify.
Next question is from me, Andrea Ceglia from the European Commission. Now you said that now we study ingredients, ontologies, and so on. Who's the chef? I mean, it's an open question. You can answer, or anybody else, or the speakers, or from the audience. Who's putting all these ingredients together?
Well, BOSCH can be the chef. You give us the data, we cook it.
No, I mean, okay. So,
but BOSCH is doing it for BOSCH.
Yeah, stars, so
who's doing it for everybody else?
Well, since I'm here at the front, please help. please come in. I mean, from my perspective, it's two things. There's one, obviously it's a governance system. I mean, that has to be in place, and so which brings me also in a way to the other part in terms of the terminologies, ontologies, and so on. The chef should be, governance organizations that make sure that there is a consistent development, that it's interoperable and so on, and of course with the OntoCommons we have laid some foundations. We have the IOF, but hopefully also in the future the IOF plus what OntoCommons has developed, and EMMC is governing for the EMO ontology. So these are very important. Then of course many parts of legislative frameworks and foundations. But the other thing is, will there be a BOSS on a commercial level, right? Will there be a commercial data marketplace in this field in the same way as there are, of course, also commercial data marketplaces in other areas? I mean, in fact, the market for data marketplaces is a rapidly growing market, but we haven't really found a way of doing that in the materials manufacturing space, I think. Please. And please say your.
So my name is Marcel Fröhlich from Essenza. I think as a guideline that is not very satisfying, agreement is temporary and agreement cannot be prescribed. So there is no point in saying this is the boss or that is the boss. It won't carry you anywhere. So there needs to be mechanism to keep that open and to defer this question to a situation where it needs to be addressed. There is no general good answer to that.
Amit.
I think it's a brilliant question, but I kind of almost agree with the person who responded. Sorry, Amit Bhave, CMCL, DOME, etc. The answer is, on a personal level, I feel let the market decide if you're talking about ownership and commercialization, and there are different ways to do that. But secondly, I think we should be encouraging the evolution. It's as I think he said, it's too early in that space, number one. And secondly, we have to develop a co-sharing model where not one chef takes it all. We need to have a cohort of chefs, and this is an uncharted territory, particularly for ecosystems. Because we know what happens when just one or two very large organizations take or be the chefs. And sorry, I'm only speaking about cross-sector, cross-domain work, so not where it makes perfect sense for the likes of BOSCH to commercialize and exploit it. It's understandable. But if you're talking about realms where you go across multiple sectors, then I don't think there's one player or one chef. just my personal thought.
There's also a question online from Circular, or if you want to speak, I don't know who the person is. How do you reconcile open and private in this case? Not sure what this exactly refers to, but also any of our speakers, please. I invite you to respond. Yes, please. Dimitris, please.
I think in this domain we're still in the exploratory phase. Now I think it works now, yes. So thank you. Again, I repeat, I'm Dimitris Kiritsis, partner in the OntoCommons, active in the OntoCommons project. So I believe that we are still in the exploratory phase in this domain, in this activity, and a lot of issues have to be
this one. I think this one doesn't cut out. There you go.
Thank you, Michela. So I think with all these projects, not only in Europe but elsewhere, so I know there are a lot of discussion also in IOF about that. So the trend is, in my opinion, that part of the ontologies that will model knowledge, which is the public domain, in the universal domain. One more? Thank you. So be careful, I will destroy everything. Yeah. Now you look like a politician.
Yeah, that's right. This is the United Nations.
So in the architecture, in this triangle that you saw, so up to the domain level, reference level, middle level, top level, so it will be open access, open source ontologies. So ontologies that are developed for industrial private users will remain private because there is a lot of know-how there. So for the moment, we have the licenses that we know. So the commons, I don't know all of them, I'm not specialist. But then the chef, the overall governance, I believe that there is a lot of value there. And I believe that we will have the intelligence to build communities or bodies that they will govern this thing. And policy departments, the European Commission, they have to play an important role there. I don't know if it will be ISO or UN or whatever, but something with a global governance will be required. Not only for the how we build ontologies, how we maintain ontologies, etc., but about the ontologies themselves. All this has to be somehow I don't know if the regulated is a good word, but managed in a common way, with respect to all stakeholders and all that stuff. And I believe that this is to come in some years because everybody agrees that the value is huge there and there will be interests. And we should not allow, let's say, mastodons like Amazon or GAFA, etc., to build. So if you leave it like that, it will be built, but don't leave it. So, but this is not the job of us, of technicians or scientists. It's at other levels. Thank you.
Okay, thank you. Thanks, everyone. I think we are kind of a bit out of time. Brief comment still from Ghedini, or
to complete regarding what Dimitris said. I mean, also regarding this private and public stuff, I think what we are trying to create is common that can be shared, so public. What we are looking for is to build what is private on what is common, because it will help when you want to share what is private in certain, let's say, in certain scope of agreement, for example, with third parties, at least you have what is common. that will help to understand your models and so on. This is at the difference level between what is private and public. So I think our role is to create those commons, and then on the private part, it's let's say it's one-to-one, and it's a matter of agreements. And another also aspect, I mean, it was amazing because Dimitris is talking about IUF. The first ideas of IUF, I mean, I had a funny discussion with Barry, with Barry Smith, where we would like to arrive. I say my dream is to have like certification on ontologies. Say, okay, this ontology is stamped, it's certificated. It means that it's follow, let's say, now OntoCommons ecosystem. It's respect the technical principles, it respect this ecosystem, it's aligned to top level and so on. So maybe also there is a work to do on this certification bodies that can, I mean, be created. Like, I mean, as a sustainability, I think IUF and also ICF as I mean, leading this, and EMMC leading the sustainability of OntoCommons, I think there is a matter of work there in order to standardize OCES and then create certification related to that.
Thank you.
This is the one.
No, actually, I think it's now working. Ah, okay, maybe it's not working. Sorry, we just have multiple devices here. Okay, try. There's several sort of parts to this answer, which kind of links to what the colleagues have said. One is on the subject of certification or something, because I mean, this is something that we have discovered when we were discussing how do you make EOSC sustainable? Because that was like a really big question, because it's not a central repository, it's a federated structure, et cetera, et cetera. So still someone has to maintain the link. And in terms of business models, it became apparent, for example, and this is something that I have mentioned before to DOME, and I've mentioned in our discussion before, which was a surprise to some of our DOME colleagues, for example, in the marketplace, that something like fair verification of data proves to industry to be really useful because it attaches kind of a certificate or a reassurance or some kind of a warranty of one type of a quality attached to the data set. And in commercial data set situations, there is nothing currently that they can use to actually verify whether this is fair or interoperable. Then, of course, there are a whole bunch of other layers to that, where the quality of data and everything else. And so, of course, certification of an ontology, for example, is equally marketable in industry, because if it is an ontology that is certified, then there is some kind of reassurance that comes into it. It has value. So that's one type of valorization that we're talking about. So there are different valorization aspects that we can implement and test and see what kind of behaviors they stimulate. Another way to valorize is through, first of all, distributed governance is definitely the way forward, so that everybody can take of their assets and they can take care of the safety and security of their own assets. And what we need is the railway tracks in between, which we have been discussing here. The management of the railway tracks, well, we can think historically of the management of all kinds of types of railway tracks and communication systems and how they have kind of been managed, if they are useful to the community. But the one thing that we can do is have layers of privacy and of proprietary data embedded in whatever passports are traveling through the system. So you can have the top level metadata that's open and searchable and fair. Then you can have layers under that you can have, that you can open based on agreements and contracts. So you can monetize on those. You can also do value added So if you do combine, for example, two different types of data sets from two different providers, and you create a new kind of data set out of that with modeling, you can then add a percentage value on top of that. And if it's valuable to people, people will pay that extra percentage value, etc. So we can embed and we can test in our systems these different layered models in which the market becomes dynamic. Because then, of course, it will start to self-adjust. It's moderated by the users and according to the value that they attach to it. Because ultimately, we will not preempt the value will be dictated by the market. So I don't know if that helps towards kind of imagining the sort of how this space may evolve.
Absolutely, and thank you very much for that. I think that rounds up the space of things that all contribute to that overall system, and we've done. And thank you very much for all of you for, I think, contributing to at least a preliminary set of answers to that question, which was given to us in the program. And we'll have a break now. Thank you. So we should come back in 10 minutes.